What is 1 square plus 2 square plus 3 square all the way up to n squared? What is this total to, right? We can write this in the summation sign like follows. K is equal to 1 to n of k squared, okay, which basically tells us that it is 1 squared plus 2 squared plus 3 squared and on and on and on. Finally we put n as k. N is the highest number and the last number in the series. What is this equal to? Let's say, for example, if you put k is equal to 4. So as we put k is equal to 4, this becomes 1 squared plus 2 squared plus 3 squared plus 4 squared. So this becomes 1 plus 4 plus 9 plus 16. This is 5, and 9 and 5 is 14 plus 16. 14 plus 16 is 30. So this is what you get if you sum up to 4. We will also verify the result after we have obtained the formula, the general formula, okay. But in order to obtain the formula for this result, how would we approach? I would recommend that you try on your own initially. It is extremely difficult if you do not know how to approach this. Any direct method will actually be very complicated, so much so you won't be able to, or maybe rarely you would be able to go to the end. Okay, so one of the result that will help us actually is this identity. You might be thinking, how did we got this identity? So let's say it's k plus 1 cubed minus k cubed. We can expand this term using the formula a plus b cubed. Recall, a plus b cubed is a cubed plus b cubed plus 3a square b plus 3ab squared. So this becomes k cubed plus 1 cubed plus 3k square b plus 3k into 1 squared minus k cubed. Indeed, k here works like a and the 1 like b. Notice something nice. So okay, so k squared into 1, this is 1 here. So this is 3k square, 1 square is 1 here, 3k square, this is 3k plus 1 cube is 1. So this was 3k, 1 square, like this. So we have written this result here, this here, so this becomes this result. You can see this exactly matches our result. Now as we just saw, we have got that k plus 1 cube minus k cube is 3k square plus 3k plus 1. Next up, we sum from k is equal to 1 to n on the both side. We sum for k is equal to 1 to n. So this is our left hand side and this is our right hand side. Initially we will deal with the left hand side and then we will proceed on to right hand side. So let's go on with the left hand side and start putting the values. So for left hand side, if you can see, as we put k is equal to 1, so putting k is equal to 1 gives you what? 1 plus 1 cubed, so that becomes 2 cube minus 1 cube. If you put next k is equal to 2, this becomes 2 plus 1 cubed, 3 cubed minus 2 cubed. As you put k is equal to 3, this becomes 4 cube minus 3 cube, and on. As you put k is equal to n, k is equal to n, this becomes n plus 1 cubed minus n cubed. This is the left hand side. The good thing about it is that it's a telescopic series. The terms cancel out and you are very nicely left with two terms. Here, two terms. Notice that this and this becomes 0, so does this, and it carries on all the way up to here. You can see clearly before that is plus n cube, so this cancels out with minus n cube. And ultimately, for the left hand side, we are left with this final term n plus 1 cube and this term 1 cube. We can then figure this one out using again the formula for the cube, a plus b cubed. So a cubed plus b cubed plus 3a square b plus 3a b squared, and finally minus 1 squared. So this cancels out, and finally we are left with n cubed plus 3n squared plus 3n. This is the result for the left hand side. Okay, tackling the right hand side. Remember, see here, this is our right hand side. This is what we have got, 3k square plus 3k plus 1. So for the right hand side, RHS, we are summing k is equal to 1 to n of 3k square plus 3k plus 1. We will distribute this because it's a direct sum. We can distribute over the numbers. This becomes k is equal to 1 to n of 3k square. Similarly, k is equal to 1 to n of 3k, and finally k is equal to 1 to n of 1. At this point, since 3 is a constant, we can factor this out. So this becomes like this, the next term becomes this one, and the final result is here. What we do next is we let this be 3 and we call this sum S. We call this sum S. So this is the sum we call S. And so how did we approach this? 3 we factored out. We are summing from k is equal to 1 to n of k. This is the sum of natural numbers from 1. So it's basically 1 plus 2 plus 3 plus all the way up to n. Okay, how would we figure this out? There's a very nice formula for that. This is n into n plus 1 over 2. You might be thinking, how can we get the result? Remember, or you can see, this is a series in arithmetic progression. So you can use the formula of the sum of n series S of n is equal to the first term plus last term. So this is the first term, this is the last term, times the number of terms divided by 2. Exactly how you would get the result. If you wanted prefer not to use the result, there is a direct approach. We can write something like so: 1 plus 2 plus 3 plus all the way up to n. All the way up to n. And then let's call this S1. We can turn that, so this becomes n plus n minus 1, the term before that, plus n minus 2, n minus 2, all the way up to 1. And as we sum it, this becomes 2s1, this becomes n plus 1, 2 plus n minus 1, this also becomes n plus 1. And if you notice, all the terms are n plus 1. This is indeed n into n plus 1. N plus 1 is n times. And therefore, as of 1 becomes n into n plus 1 over 2. This is the final result that we have got. Looking at this result, we are summing k is equal to 1 to n 1 times, this becomes n. So finally This is our right hand side. Next up, we would equal the left hand side with the right hand side. So here we are. This is what we got. uh, if you go before, this is the result with the left hand side. So this is, and this is the result with the right hand side, and from here on we have to solve for the s. Well, notice something. uh, we can do this much easily. Let's factor out 3 from this side. So as you factor out 3, this becomes n cube upon 3 plus n square plus n. We will also factor out 3 over here, so it becomes n into n plus 1 over 2 plus n over 3, and we can cancel out 3, and s becomes, we will move this 2 on the other side, n cube upon 3 plus n square plus n minus n into n upon 2 minus n upon 3. Okay, it's time for the LCM. The LCM of the 2 is 6. 3 times 2 is 6, so this becomes 2. 10 cube, this becomes 6. This becomes 6 n square. This becomes 6n square, and then plus 6n and minus 2 3 ja, so this becomes 3n into n plus 1, and finally 2n. Okay, we can solve this a little bit. 2n cube, there are no n cube terms. This is 2n cube. There will be an n terms, n square term, but after expanding this, so let's keep it as such as of now. 6n minus 2n, that becomes 4n. Let's do that. Minus 3n square after distributing, minus 3n whole upon 6 to n cube. N cube remains like so. 6n square minus 3n square is 3n square, and 4n minus 3n is n upon 6. Let's factor n out, so this becomes 2n square plus 3n plus 1 upon 6. Okay, now how do we proceed from here on? And we have to factor this. See, upon multiplying, we need 2 numbers that multiply up to 2, and a number added results in 3. 2 such numbers are 3 and 1, right? No, it's actually 2 and 1. 2 and 1. So we write it as 2n square plus 2n plus n plus 1. We have written 3n as 2n plus n whole upon 6. We can factor 2n out, so this becomes n plus 1, and then here factoring 1 out gives us n plus 1. The 6 is here. N into, we can factor n plus 1 out, so we are left with 2n plus 1 upon 6. This is the final result. N into n plus 1 into 2n plus 1 upon 6. Okay, so this is the final result, that the k square is this number. Okay, we tried that. If you remember, for k is equal to 4, our result was 30. Let's check this. So we will put n is equal to 4, n was 4, right? We put n is equal to 4, sorry, 4 into 4 plus 1 into 2 into 4 plus 1 upon 6. This gives us 4 into 5 into 819 upon 6. We can 3 2 jar, 3 3 jar, 2 2 jar, 5 2 jar, 10 into 3. This indeed gives us 30, which is the correct result indeed. And therefore we can actually write this more clearly as sum of n square, let's say for example here n is equal to 1 to n is n into n plus 1 into 2n plus 1 whole on 6, like this. I hope you understood.